Today we'll be solving exponential equations again. However, these problems will be more challenging because we will have to change both sides of the equation to get the same base and then set those exponents equal to each other so we can solve. So going through the first problem, you will notice that there is no way I can take this 125 and write it as a base of 25 in order to get these two sides to be equal. Because 25 to the first power is 25, 25 to the second power is definitely not 125. So if you look at each side, I can actually rewrite this 25 as 5 squared. On the right-hand side, I can write this base as 5 cubed. Now, I am going to set the exponents equal to each other, but the first thing I need to do is actually distribute here. This is a power to a power, so what I end up getting is 5 to the 2x plus 2 power equaling 5 cubed. It is very important that you distribute here. It's a common mistake that people make. Now from there, we get the same base, so then we can set our exponents equal to each other and solve. Same thing with the next problem. If you notice right away, you can't get a base of 4 on the 32. So what we can do is rewrite this 4 as 2 squared, and then rewrite this 32 as 2 to the 5th power. Now, before I actually set the exponents equal, I'm going to distribute that 2 because of the power to the power, and then I can set my exponents equal to each other. You are more than okay to leave that as a fraction. If you want to write that as 5.5, that's okay too. Now, with the next set of examples, you're going to notice this idea of, oh wait, we can get the same base by just changing one of the sides, but notice now the complexity of the exponents. So I could still take this 25 and write it as 5 squared to get that same base. But as I said, you're going to see that the other side has a more complex exponent. Now distribute, as we did in the last problem. And then we can go ahead and set these exponents equal. So we have a 4x minus 2, 9x plus 12. We can bring the x's on one side. Doesn't really matter, I guess, which side we move. Then we can bring that 2 over to the other side. I don't like the way that looks. Let's try that again. X equals 14 divided by negative 5, and it doesn't matter as long as you have the negative somewhere on there. A lot of people like to put that in the front, so I'll put that in the front. A little like negative there. But negative 14/5 as your final answer. For this next problem, be careful. I know some of you might be thinking, oh, 8, that's 4 times 2. But 4 to the second power isn't 8. So unfortunately, that's not going to work out here. We are going to use this base of 2 because we can also write 8 as 2 cubed. So we get 2 to the 2x power equaling 2 to the 3x plus 3 power. And then we could go ahead and set those exponents equal. That was me subtracting 3x. And then we could divide by negative 1. All right, a couple more problems, and then you're going to have some to try on your own. Same thing here. I'm seeing that I can't rewrite 64 as a base of 16. I do know that I could write each of these with a base of 4. I also think you could do both of these as a base of 2. But I'm going to go with the bigger number here just because I thought of that one first. And then we can distribute the exponent. So 2x plus 10. Hold on. Put that base of 4. Equaling 4 to the 3x. And then we can set our exponents equal to each other. And then I'm actually going to move this over to the other side. You could do it the other way, but that's going to save me one step at the end to get that solution of 10. And then final problem in this set, we have two problems, or two sides. Again, I'm seeing these 2's, this commonality of 2. So I'm reminding myself that I could actually rewrite this as 2 to the negative first power. 3x plus 1. And then I'm going to leave the other side the same. Then I can distribute this negative 1 over here. And then I'm A-okay to set those exponents equal to each other. Can add the 3x to both sides. Show that work. So we get 5x minus 5 equals negative 1. And then I can add the 5 to both sides to get 5x equals 4. And then divide by 5 to get 4/5. So at this time, I'd like you guys to pause the video, do the you-try problems, and then once you're ready to check, as I said on the other video, you can either just scroll to the end to see if you got all 4 answers right, or you can listen to my explanation of each. Pause now. Did you pause yet? You didn't pause yet. I bet you didn't pause. Pause. Seriously, pause. Okay, hey, welcome back. So let's look at these 4 problems and see how you did. So I see right away this 927. I'm going to rewrite this as 3 squared. And I'm going to rewrite this as 3 cubed. I will then distribute the exponent. And then I can set those exponents equal to each other. Again, decimal form or improper fraction is fine with me. Next one, I see that I can actually keep this as a base of 6, but I do need to write this one as 6 squared. Uh-oh, I hear someone waking up. For this next problem, you will see that the 100, 1000, I'm thinking 10 to the second power here, and then 10 to the third power here, and then I can distribute the exponents, and then I can set my exponents equal. I do ask that you reduce here. Since they're both divisible by 2, we can get 5/2. And then the final problem in the set, don't forget we can go about getting the same base first. So combine that, and then don't forget we're adding those exponents. And then following that, to get that same base, I see this as 5 squared. See this as 5 cubed. We can distribute the exponent. And then we can set those exponents equal to each other. So I hope you did well on these problems. Email me with any questions.